Hello, you are welcome to our regular class on SLM 305. And our topic today is soil reaction and lime requirement. I'm your regular host, Dr. Godwin A. Al-Hassan of the Department of Crop and Soil Sciences, Faculty of Agricultural Sciences, National Open University of Nigeria, Kaduna Campus. Soil reaction is a measure of the quantity or amount of alkaline or acid that is contained in the soil. It is a measure of the pH level that is in the soil, and it determines the activities of soil microorganisms. And the activities of these soil microorganisms that are controlled by the level of the acidity or alkalinity of the soil is what we are going to discuss in this our topic 5, soil reaction and lime requirements. It's an interesting course. I want you to relax and enjoy yourself as I take you through the slides. God bless you. Uh, you are welcome again to our topic 5, soil reaction and lime requirement. I am once again your facilitator for this course, Dr. Godwin A. Hassan of the Department of Soil and Crop Sciences, National Open University of Nigeria. By way of introduction, the soil reaction measures the relative amount of acid or alkaline in the soil. The amount of acid in the soil has implication on soil nutrients. It determines the ability and type of microorganisms that thrives in the soil. Soil reaction has indirect effects on the decomposition of organic materials that are contained in the soil. It is measured by soil pH meter. Liming is aimed at solving the problem of soil acidity and application of liming material that is either natural or synthetic that will bring our soil condition to the required pH level. Objectives. We have 5 main objectives for this topic. We want to state the definition of soil reaction, discuss the causes of soil acidity, discuss the importance of soil pH, state soil lime requirement, and know the method of its determination. Soil reaction. The degree of acidity or alkalinity affects soil properties. Soil acidity is the total amount of acid present in the soil. The soil reaction is expressed as the soil pH. pH is a measure of the relative acidity or alkalinity of the soil. 4 ranges of the pH are of good information. 1. A pH less than 4 indicates the presence of free acids. pH less than 5.5 indicates occurrence of exchangeable aluminum. And pH of 7.8 to 8.2 indicates presence of excess calcium carbonate. And pH greater than 8.5 indicates the soil is with high exchangeable sodium, that is alkaline or sodic soils. pH scale. The pH scale ranges from 1 to 14, but the soil pH varies between 3 to 9. A neutral soil has a pH of 7. At pH 7, the number of hydrogen ions and hydroxy ions are equal. Active acidity is that is measured by the soil pH. Reserve acidity is that is left within the soil microcell. It is usually measured by titrating the soil solution with the base. This is the pictorial presentation of soil alkalinity and soil acidity. At pH of 0 to 5 is considered to be acidic. Neutral is 6, 7, and 8. And then 9 to 14 are considered as alkaline. What are the causes of soil acidity? 1. Leaching, stroke loss of bases like calcium, magnesium, etc. 2. Application of acid-forming fertilizers, e.g. urea and ammonium-based fertilizers. 3. Acid rain. 4. Decomposition of organic matter. That is where carbon dioxide is involved. It is mixed with soil water to form weak carbonic acid. 5. Hydrolysis of aluminum oxides and hydrogen oxides. Importance of soil pH in crop production. Determining the availability of plant nutrients, e.g., phosphorus is available maximally at near neutral pH. pH influences the availability of toxic amounts of minerals and elements that may reduce crop yield. For example, at low pH, iron and manganese are present in toxic amount in the soil. It influences the population and activities of beneficial microorganisms in the soil. That is the pH. The picture we are seeing is the pH quick text for soil pH. Soil text for at least pH is essential before you apply fertilizer and any other soil amendments. Lime materials. Soil acidity is commonly decreased by adding carbonates, oxides or hydroxide of calcium and magnesium. These compounds are referred to as agricultural limes. Wood ash is used locally to help control soil acidity. Lime requirement. Lime requirement is the amount of liming material required to bring about a desired pH change. Amount of lime required to raise a soil from 1 pH to a desired pH value, and then lime requirement is determined by the following methods: the change of pH required, the buffer capacity of the soil, the chemical composition of the liming material, and the fineness of the liming material. Methods of determining lime requirement. Field plot techniques is number 1. Apply raise, plant and monitor for at least yield and best rate performance. Titration with a base, soil solution with a base. Incubation studies 8 weeks with different rates of lime test for best pH. Use of buffer like Woodruff buffer, Adams and Evans buffer, etc. Adsorption and desorption. The three states of matter, solid, liquid, and gaseous phases, could interrelate with each other without having one of the phases consumed by the other phase. Water could be held on the surface of a solid, while gases could also be held on soil material. The same applies for dissolved soil nutrients and soil colloids. Adsorption and desorption continues. The nutrients in solution are held on the surface of colloids because of the different charges, positive and negative charges. This surface phenomenon is called adsorption. This is opposed to absorption, where an entity penetrates the inner surfaces of the other phase. The release of adsorbed materials is called desorption. In this, so Adsorption. So in this unit, the concept of adsorption and desorption and the forces involved in the process. Adsorption, absorption and adsorption in soils. The difference. Absorption. The process through which ions or molecules are removed from the solution and accumulate within existing solid constituents. Adsorption. The process through which ions or molecules are removed from the solution and accumulate on solid constituents at the solid-liquid interface. This is the pictorial presentation. Adsorption, it is the ions are on the surface of the molecules, and then absorption, they are within. So there is a penetration. When we talk of absorption, is located within, while adsorption is at the surface level. Adsorption characteristics. Adsorption is determined not only on the surface charge but also on the surface area. Adsorption and desorption are reversible. Energy is released during adsorption process. Adsorption is less at high temperature. Forces of adsorption. There are 6 forces. physical forces, hydrogen bonding, hydrophobic bonding, electrostatic bonding, coordination reaction, and ligand exchange. Thank you very much. See you next week, same time. I am yours again, Dr. Gordon Al Hassan. God bless you.